video, when we left it in our last video. So we're talking about the types of pollination, self-pollination and cross-pollination. So we were talking about the features that favor cross-pollination. So that's where we are continuing from today. So we are talking about the features that favor cross-pollination. Now, there are some important features of a flower that favor cross-pollination. There are some characteristics that a flower would have that would enable it to carry out the cross type of pollination. So I want to talk about those features or those characteristics. Now the first one is unisexuality. Now in dioecious plants like the pawpaw, those are plants that have separate trees for separate flowers. So the male flower is born, or it is found on a separate tree. The female flower is found on a separate tree. So in dioecious plants, only cross-pollination can occur because the male and the female flower are on separate plants. So we can't have self-pollination. We can only have cross-pollination in dioecious plants. Now, such plant species, they have features, or they have perfected their adaptation for carrying out cross-pollination. So that's that for dioecious plants. So we are still talking about unisexuality. And unisexuality, when we say unisexuality, we are talking about the fact that each flower has one sex, unlike bisexuality. In bisexuality, the two sexes are found on one flower, but in unisexuality, each flower has a separate sex. So we said in dioecious plants, only cross-pollination can occur. Now in monoecious plants like the pumpkin, oil palm, maize, and so on, self-pollination is possible. So self-pollination can occur in those monoecious plants, but the likelihood of self-pollination occurring is reduced because it could be reduced in this following situation. So the likelihood of self-pollination occurring in this monoecious plant is reduced because of some following features. So if the female flowers are above and the male flowers are below, the likelihood of self-pollination occurring is reduced. So it's not possible for self-pollination to occur in that kind of situation when the female flowers are above the male flowers. Now another situation where the likelihood of self-pollination occurring is reduced is when the male flowers and the female flowers ripen or mature at different times. So self-pollination it's not easy for self-pollination to occur if when the male parts are matured before the female parts, or the female parts mature before the male parts. So self-pollination cannot occur in those situations. Now in the case we just mentioned, what happens is that the plant then functions as a male plant when only the male flowers are mature, and it functions as a female plant when the female flowers are mature. Remember we said it's a monoecious plant, and on the monoecious plant we have both male and female flowers. So the plant will function as a male plant only when the male flowers are mature, and as a female plant when the female flowers are mature, so that it can carry out pollination successfully. So another feature that favors cross-pollination in plants is dichogamy. Now, most species of flowering plants usually bear bisexual flowers. Generally, most species, they usually bear flowers that have both sexes, both the male and the female sexes. So this plants usually prevent self-pollination by having flowers in which the stamens and the carpels mature at different times. So the way the plant can prevent self-pollination, but not intentionally of course, but when the male parts are maturing before the female parts, when the stamens are maturing before the carpels, or the carpels are maturing before the stamens, that's the male and the female part, self-pollination cannot occur. So such dichogamous flowers function as male flowers when the stamens are mature, and as female flowers when the carpels are mature. So in that way, cross-pollination can occur because they are dichogamous flowers, in that they can change their function. The flower can change function to suit the need at that point. So, for example, if a flower has the stamens and the carpels, and the stamens and the carpels of that flower are maturing at different times, what will happen is that the stamens, when they are mature, the flower will function as a male flower. Then it will go through pollination with another flower. So pollination can occur easily. So the pollen grains will be transferred to the anther of that of another flower. So when the carpels of the flower are mature, it will function as a female flower. So the pollen grains can be brought from another flower to the flower that is functioning as a female flower. So that is dichogamy. The flower is functioning as different sexes of the flower at different times to suit the needs of the plant or the flower for pollination. Now let's talk about self-incompatibility also. That's the last feature of flowers that favor cross-pollination. Self-incompatibility. Now, the bisexual flowers of some plants or some species may bear mature stamens and carpels at the same time. So we mentioned when we're talking about dichogamy that most of the times the bisexual flowers do not mature, the stamens and carpels do not mature at the same time. But they can mature at the same time also. The stamens and the carpels, they could mature at the same time. But however, if the pollen grains fall on the stigmas of the same flower, or it falls on the stigmas of another flower of the same plant, and they can fail to germinate. So this is called self-incompatibility. Now this feature favors cross-pollination because when the pollen grains fall on the stigmas of the flower of that same flower, or it falls on the stigmas of another flower on that same plant, it fails to germinate. So that plant is experiencing a condition called self-incompatibility, and it's an inherited condition of plants. So because of this, only cross-pollination can occur in those kind of plants. Now examples of plants like this that have this feature are passion flower and tea. So those plants, they have self-incompatibility. So with that, we've come to the end of today's video. In our next video, we'll talk about pollinating agents that carry out pollination in plants. See you in our next video.